before.
Starting the chapter 5, and we're going to talk about graphing some different types of functions. We've been doing polynomials, and now we're going to get into rational functions. So first we need to talk about what it means to be a rational function. So it's anything of the form p over q. P and q are just polynomials. So you get a rational when you divide two polynomials. And of course, if we're dividing, we know that the bottom cannot equal 0. So a lot of times we're going to talk about the domain of this, and we have to then make sure the bottom isn't 0. That's the only thing that can't happen. Those places where the denominator is 0, that's where our graph is going to do some different things when we get into the graphing piece. So I want to start just practicing finding the domain. When I ask for the domain, you don't have to simplify anything first. It doesn't matter if something would factor out and cancel, because if it's in the denominator in the original, we have to go ahead and say it can't equal 0. So for A, if I'm trying to find this domain, we just look at the bottom, and we say that x plus 5 cannot equal 0. So if we subtract over our 5, then x cannot be negative 5. So how would I write that in interval notation? Everything except negative 5, so that would be Alright, the second one. If I have x squared minus 4 on the bottom. So the only thing I'm looking at when finding the domain is the denominator can't be 0. What would you do?
I have 4 over and plus and minus it and square
So
off.
x cannot equal positive or negative 2. As an interval, think about this. You can be everything except those values. So you can be everything less than the negative 2. So that would be negative infinity to negative 2. You can be everything in between those values. Thank you. So that would be negative 2 to 2. And you can be everything bigger than 2. So that's 2 to infinity. Okay, so in general, my rule is if there's only one value x cannot equal, I expect the interval. On a test or quiz, if you had multiple values that x couldn't be, I won't make you write the interval, but just know MathXL may ask for it, so that's why I'm having you practice it here. But on a test, if there were 2 or 3 values that x could not equal, and you just listed them, I would accept that. Alright, let's look at C. So if we're finding the domain, we know the bottom can't equal 0. So x squared can't be a negative 1. If we square root this time, we get x cannot equal plus and minus, what's the square root of negative 1? I. Okay, in terms of graphing that, do we graph the i's? No. So what do you think that would make my domain? Negative infinity to positive infinity. If you get an imaginary, then we don't have to consider that. X could be anything. Remember, the domain is just asking what values could you plug in for x. Alright, D. If you set the bottom equal to 0, does 3 ever equal 0? No? So what's the domain? E. So if we say this cannot equal 0, then x cannot equal 1. So how would I write my domain? Any questions about how we find domain from a rational equation? Is that your denominator equal to 0, and those are the things x cannot be. Now I have a question for you. This last one, x squared minus 1 over x minus 1. If you factor the top, how does x squared minus 1 factor? So then what would happen to the x minus 1s? And we get x plus 1. So my question is, are these equivalent then? They're reduced to the same thing. So that would lead us to kind of say, yes, they're equivalent, but there is a difference when we graph them. Because, what's the domain of this one? What did we say our domain was? We said it cannot be a positive 1. But this one, there is no fraction, so what's our domain? Negative infinity to positive infinity. So you can plug a 1 into this one, but this, as it's originally written, you cannot plug a 1 into. We'll talk, it'll be a couple sections before we really get to what that does to the graph. But right now, they are not the same because the domains are different. We said this one will be a negative infinity to positive infinity, and we did this one on the last example, the negative infinity to 1. So to be equivalent, functions have to look the same and have the same domain. And the domain is based off the original equation, not what it reduces to later on. Okay. The next piece that we are going to talk about is asymptotes. When I'm talking about an asymptote, that is a line that our graph is approaching without actually touching. So it's just going to always get closer and closer to that line, but never actually touch it. There are 3 types of asymptotes: horizontal, vertical, and oblique. Sometimes you might see this oblique one called a slant asymptote. Sometimes on the ACT they can use either term if they're asking you to identify it. It is possible for a function to intersect a horizontal or an oblique asymptote at some point, but it will never ever touch a vertical one. So the rest of the day today, we're just going to look at some graphs and identify where we have each type of asymptote. The first one I want to look at is the reciprocal function, 1 over x. Let's just do a t-chart and kind of graph this, and then we'll answer questions about it. Okay, so if we plug in a 1, we get out 1 over 1 is 1. If I put in a 2, 1/2. If I put in a 3, okay. So if I plot those, what would happen if I put in a 1/2? What's 1 over 1/2? To divide by a fraction, you flip and multiply, don't you? So we get 2. So if x is a 1/2, we get out a 2. If x was a 1/3, then we would get out 3. Can we plug a 0 in? Can we do 1 over 0? Okay. What if I put in negatives? If I put in -1, what do I get out? If I put in -2. If I put in -1/2.
Oh, -1/2. -2.
Yeah. Okay, so if I plot those, did a negative 1/3. Negative 1/2 gives you a negative 2. If you did a negative 1/3, you get a negative 3. We said we can't plug in 0. Will you ever do 1 divided by something and get 0 for an answer? No. What our graph looks like, it's just a curve approaching the x and y axis, but we never actually hit them. The x and y axis in this case are what we call asymptotes. They're the lines we're getting close to but not touching. Usually if I draw those in, we draw them with a dashed line, just to show we're approaching that line, but not actually hitting it. So now let's answer some questions. Domain, we could have found that from the original. We already said we couldn't plug in a 0. We can also see it from the graph. I'm coming from negative infinity. This piece stops at 0. Next one picks up and goes forever. So our domain, negative infinity to 0, union 0 to infinity. Range, talking about the y. So you go from the bottom up. So it's going down forever, so it's coming from negative infinity. Stops when we get right here, which is 0. Union picks up again after 0 and goes to infinity. Vertical asymptotes. Your asymptotes are lines, so I expect them to be written as equations. A vertical line is always x equals a number. So what is the vertical line that we never touch? Right here, that's when x is 0. Horizontal asymptote, horizontal is y equals a number, and the horizontal line we don't touch is y equals 0. Notice those were the two values that were not included in our domain and range. Even or odd? Even means symmetric to the y-axis. In other words, if I fold this thing on the y-axis, does it overlap itself? No. Odd, if you remember, means symmetric to the origin, which means you have to flip over both the x and the y. So think about this top piece. If I flip it over the y, it will go right here. And then if I flip that over the x, it's right here. So that one works. This one is odd. It's symmetric to the origin. Any questions there? Let's look at variation index. Now that we know what 1 over x looks like, we could use transformations to get the other piece. What would this plus 1 do to our graph? If you add to x, you go to the left. Remember, if you're adding, if it's attached to the x, it moves left and right and does the opposite of what you think. So adding moves it in the negative direction. So if we think about the original 1 over x, I am not going to put a lot of points here. I'm just going to roughly sketch this to show you. So this was the original 1 over x graph we just graphed. I'm only putting the 0.11 and negative 1 on there. When you move that to the left, you have to move your asymptotes with it. So we had a vertical asymptote at 0. So when I move it to the left, that vertical asymptote is now where? Negative 1, right? If you go left 1. The other way we could tell that, what's the one value x cannot equal?
0.
The bottom can't be 0, and that happens when x is negative 1. So that's your vertical asymptote. So then if we move this 0.11 left 1, it would go here. If you're only moving left, your horizontal doesn't move. So there's that section. If I move -1 left, then it looks like this. Now you could certainly make a T-chart if you needed to. You can double check yourself on a graphing calculator, but not too difficult to use our transformations that we had in the past. My domain, we can get it either looking at the function or looking at the graph. What's the one value x can't be? -1. So our domain is -infinity to -1, union -1 to infinity. The range is my y. If I look at my graph, what's the one value we didn't hit? 0. We had a horizontal asymptote right here. So our range, -infinity to 0, and 0 to infinity. I asked for asymptotes, so vertical asymptote is always x equals, what was that x value? -1. Same thing that we took out of our domain. Horizontal asymptote is y equals, and it's just the value you took out of your range. So it's at y equals 0. Let's try one more like this. What are my transformations this time? What does that -2 do?
Down.
And what's a negative do?
Flips.
I'll flip it over the x-axis. Okay. So if I just graphed a really rough sketch of my parent function, just so we remember what the 1 over x looks like. Okay. If I move this thing down, that would move my horizontal asymptote. Moving it left and right switches your vertical, moving up and down moves your horizontal. So my horizontal asymptote is now going to be at -2. I'm just going to go ahead and draw that in. Okay, if I flip this thing, so if you took that curve and flipped it over the x, it's down here. So this point would move here, and then when you go down 2, it would look like this. This side, if you flipped it over the x, it would be up here. And then if you move it down 2, looks like this. And you could certainly use a graphing calculator to check yourself or plug in a few points. Since we just moved up and down, it didn't move the vertical asymptote, so that's still right here. If all these extra marks confuse you, feel free. If you need to erase that black one so you can see your final curve better, that's fine. So my domain is what? -infinity to 0, union 0. So that means my vertical asymptote is at x equals 0. Range is what? Where do we break at our graph? We go from -infinity to -2. Union -2 to infinity. So our horizontal asymptote was at y equals -2. It was at 0, we moved down 2, so now it's at the -2. Any questions on that?
I don't understand a domain.
Okay, it's just talking, you can look at it from the equation or from the graph. From the graph, it's going left to right. So it's going forever in the negative direction, stops right here at the line we don't cross, which was 0, then picks up after that and goes forever in the positive. Or, if you look at the graph, we know the denominator, which is just x, cannot equal 0. So it's everything except the 0. You're welcome. Other questions?
So basically, wherever you put the dotted line first is where your that's how you got -2.
Mm-hmm.
Is that where you got it from?
The range in the horizontal?
Yeah.
Yes.
Okay.
Other questions? One other type of function I want to look at today is the reciprocal square function. Alright, so let's just graph this first one and by plugging in a few points. If I put in a 1, 1 over 1 squared is 1. If I put in a 2, 1 over 2 squared, 1/4. Let's say if I put in a half, 1 over 1/2 squared would be 1 times 4, which is 4. So this piece is looking similar to the last one, just a little steeper. If I put in a negative, 1 over -1 squared would be negative squared is a positive, and so we get 1 again. So if I put in -2, we get a positive 1/4. If I put in a -1/2,
-4.
positive 4, right? Because when we
Yeah,
square it, it
squared,
becomes
yeah.
positive. Okay. So this is the 1 over x squared. Domain. We can get it from the function, or looking at the graph, what's the one value we don't hit? 0. So domain would be a -infinity to 0, union 0 to infinity. So that means the vertical asymptote is at x equals 0. Range. You go from the bottom up, this thing starts after 0 and goes up forever. So it's horizontal asymptote, the horizontal line we don't cross, is at y equals 0. Is this thing even or odd? Even means symmetric to the y-axis, odd is symmetric to the origin. Symmetric to the y, so it's even. If you guys have this stuff written down, then you have the first few Math Excel questions done. Because it's just going to say, consider 1 over x. What's its domain? What's its range? Where is its asymptote? So if you write all this down, you have all the answers to those first questions already on your paper. I just want to look at one transformation of this, and then one graph, and then I'm done. Let's graph this and give the domain and range. So we can certainly graph with a t-chart. We can use the graphing calculator to help ourselves, but we could also use transformations. What will this -2 do? Right, 2. And this -4? So if you think about this, we're graphing the 1 over x squared. Okay, I'm not going to put a lot of points on here, just really rough. This is like our parent function. When you move it left and right, which asymptote does it move? The vertical or the horizontal? we're going left and right, it moves the vertical. So my vertical asymptote was at 0. If I go right 2, it's now at positive 2. I like to move my asymptotes first. My horizontal one was at 0, so if I go down 4, it would move to negative 4. So now I just take my points, right 2, down 4. So moving left and right moves the vertical, up and down moves our horizontal. Okay, I have to take this phone call real quick. Sorry about that. What's the domain? Range?
Oh, negative 4. It'd be negative 4 to infinity. Yeah.
I didn't ask for it, but what's the vertical asymptote? X equals 2. Horizontal would be y equals negative 4. Good. Alright. Final question. I'm just going to give us a graph and we're going to answer domain, range, asymptotes just looking at the final graph. Okay. Domain and range. It might help in this if I drew in the asymptotes. Where does the vertical asymptote look like it should go? At 2. Horizontal?
2. 1 and
Probably about 1. Okay. So my domain, we're hitting everything except 2. It's negative infinity to 2, union 2 to infinity. That means the vertical asymptote is x equals 2. Range. What y values do we hit? Everything except 1. So that's negative infinity to 1. So that means my horizontal would be y equals 1. I did ask a couple other questions. What's the x-intercept? Where do we hit the x-axis? 1. What's the y-intercept? Approximately 1/2. Oblique asymptote, we haven't really seen any of those today, and we're not going to yet. An oblique asymptote is just any line that isn't vertical or horizontal. So there is none in this. Do you guys have any questions for me? So we have like 17 minutes. There is a Math Excel 10-question assignment for you. So go ahead and start that and let me know